Greetings everyone and welcome back. Here's something fun. The Arduino Retro Game Controller was built from scratch using a custom PCB and couple of 3D printed parts. The Arduino Micro, which has an Atmega 32U microcontroller with HDI compatibility, is being used here to transform the microcontroller into a game controller. The goal was to put together a game controller that would allow user to play Pokémon games using an emulator. Here we choose an all button controller that does not have an analog or thumbstick, but we have included two joysticks on the main PCB that will be used in the project's second revision. Along with a few resistors that are connected in series with each button, the buttons are positioned on the top side of the board. In this case, all the buttons data is being read using a single I/O pin. Along with the two 3D printed handles that are connected to the left and right side of the circuit, the Arduino Micro is positioned on the bottom side of the board. When this controller is plugged into any device, Windows, Linux or even Raspberry Pi, it registered as a game controller. All the user has to do is to map the keys and start using it. We began the project design by drawing a basic concept that was based on the layout of a typical game controller, which has a PCB in the middle that houses all the components and two holding supports on left and right side. First, we created the PCB that is attached to the circuit left and right handles. The Arduino Micro is located on the back side of the board while all the buttons are positioned on the top side. With 0.4 mm nozzle and 0.2 mm layer height, we use transparent PLA to 3D print the handle components. The Arduino Mini, which serves as the project main microcontroller, is connected to 12 buttons in particular sequence order. Here we constructed an arrangement that resembling a voltage divider using 12 1 kilo ohm resistors connected in series with button pins and VCC. The switch has resistor linked to one side and ground connected to other. An analog pin receives a value when button is pressed. By reading this value, we can identify which button is being pressed. This makes it simple to integrate 10 to 20 buttons into a single I/O pin. In the schematic, we have also included two thumbsticks that will be used in a future project. Following the schematic preparation, we made the board file and used the CAD file layout to place every component correctly. Following the completion of board design, we ordered a PCB with white solder mask with black seal screen and submitted the PCB's Gerber data on PCB-based code page. PCBs were received within a week and the PCB quality was outstanding. Here we have added a few design elements on the board cell screen layer to increase the aesthetic appeal of this project. PCBWay made the custom layer properly, which shows their great PCB manufacturing capability. Also, PCBWay is hosting its 7th project design contest, a global competition that invites electronics enthusiasts, engineers and makers to showcase their innovative projects. This year competition includes 3 major categories: the electronic project, the mechanical project and STM32 project. With prize awarded for most exceptional design, the contest aimed to inspire and support innovation, making it an exciting opportunity for both professional and hobbyists to gain recognition and connect with like-minded creators. You guys can check out PCBWay if you want great PCB service at an affordable rate and low price. We start by adding 1 kilo ohm 1206 resistor in its place by using a soldering iron. Here we first add solder to one pad. Then use a tweezer to pick up the resistor and melt the solder that we just applied to the first pad. The resistor was then firmly fixed in place by applying solder to the other pad. By following this method, we added all 12 resistors in their place. Next, we place all the push button in their proper location, including the both horizontal and vertical buttons. We secure them in place by attaching solder wire to their pads from the back side of the board. Next, we attach two Con 12 header pin from the back side of the board to the Arduino Micro's footprint. Next, we added the Arduino Micro in its location on the Con 12 header pins. We begin the final assembly step by inserting the threaded insert in 3D printed handle mounting holes. Next, we use our soldering iron tip to heat this insert, which force it into place. For each of the 4 mounting holes, we followed this procedure. Next, we use 4 M3 bolts to attach the left and right side 3D printed handle to the circuit. The assembly is now completed. We created a basic sketch for this project code that is based on the gamepad library, which you must install before using the sketch. In this sketch, the single button, the A0, is used to read the various values when any button is pressed. For instance, the pressing up button yields a value of 0. Pressing the down button yields a value of 511. Value for each buttons are different. For each button, if the analog value from A0 falls within a specific range, the corresponding button is marked as pressed. Otherwise, it is released. In following code section, the microcontroller checks the value of A0 and set the gamepad buttons accordingly. The code reads an analog input pin A0 and uses the predefined range of values to simulate the press and release of gamepad button. Each range corresponds to a different button: up, down, left, right, trigger and phase buttons like A, B, X, Y. The gamepad object GP handles the state of these buttons by using the setButtonState function. To get value of each button, we use analog serial read sketch from the example menu and use it to get value of each button. Next, a table is prepared for recording all the values, and tolerance value of +5 and -5 are added to the actual value. The tolerance value will be entered into the main code. The result of this little project is a functional game controller that can be used to play retro games. Using a PC NDS emulator, we launched Pokémon Platinum, one of the best Pokémon game ever made. Prior to anything else, the button layout need to be configured. This was accomplished by choosing the emulator controller configuration and entering the button layout in the configuration. The controller was extremely responsive and worked smoothly. In addition, we would appreciate PCBWay support of this project. Visit them for a variety of PCB related services such as stencil service, PCB assembly service, as well as 3D printed services. Thanks for reaching this far, and I'll be back with a new project pretty soon. Peace out.